Hello everyone. In our previous video we were given a fair introduction into exponents. Now let us look at a few examples based on whatever we've learned. So let's say we'll have to work out 2 to the power 5 multiplied by 2. A quick review before I start. What is 2 to the power 5? 2 to the power 5 is just you'll have to multiply 2 repeatedly 5 times. Repeated multiplication of 2 5 times. This is exponents is just a notation for representing numbers, and sometimes numbers are very large or very small. This notation comes in handy in those times. And here 2 is what we call the base. We call 2 as the base and 5 is referred to as the exponent. So coming back to our example, we have 2 to the power 5 multiplied by 2. That is, we'll have to repeatedly multiply 2 5 times as said before, and 1 2 3 4 5, yes, and then multiply by this standalone 2. So what do we get? We get 6 times 2 raised to the power 6. So 2 to the power 5 multiplied by 2 can be written as 2 raised to the power 6. So second example, let it be a fairly larger power. 4 to the power 5 multiplied by 4 to the power 8. So it's a repeated multiplication of 4 5 times first, 4 into 4 into, so this is 5 times, and multiplied by same 4, and this is going to be multiplied 8 times, right? So how many 4s will I be having? I would be 5 4s here and 8 4s here. So if I count, it would be equal to 5 plus 8. So I can represent this as 4 to the power 13, right? If you can count it and verify it in case you have a doubt. So 4 to the power 5 into 4 to the power 8 is 13. And exponents can be extended to algebra also. Suppose you have the variable t, and you will have to find out what is t to the power 3 multiplied by t raised to the power 2. It's the same as before. You just repeated multiplication of t 3 times and then 2 times. So the answer would be, or a simplified exponential representation would be t raised to the power 5, right? So let's have another example. This is 3 squared, 3 raised to the power 2 into 2 raised to the power 3. So if you write it, 3 is multiplied 2 times into 2 is multiplied 3 times. This one cannot be combined like the previous ones which we saw, but of course we can simplify this, because 3 into 3 is 9, and 2 multiplied 3 times is 8, and 9 into 8 would be 72. So a simplification is done here. And let me have one more example which would generalize whatever we have seen so far. Let a be the base, a raised to the power m multiplied by a raised to the power n. So what would this be? We are going to multiply a m times first. So a would be multiplied m times, right? And then that would be multiplied again by n times a. So what would be the simplified representation of all of these? So m times a is multiplied and n times a is multiplied. So totally I can write it as a raised to the power m plus n, right? And this is called the product rule of exponents. If you want to verify each one of the above examples, now let me write this again. And so this is the rule which we were aiming for with all these examples. A raised to the power m multiplied by a raised to the power n is a raised to the power m plus n, where m and n are whole numbers as of now. Later on we will see other kinds, but as of now we can have m and n as whole numbers. Now let's verify whether this rule which we have generalized and formed just now is satisfied by all these examples. Look at the first one. 2 raised to the power 5 and multiplied by 2. Yes, the bases are the same. The base is 2. Just like in our rule, the base is a, right? The base has to be the same for this generalization. So the bases are the same. So 2 raised to the power 5 and multiplied by 2 is giving us 2 raised to the power 6. So this has to be 1, right? Because 2 is multiplied just once. So we can write it as 2 raised to the power 1. So if you apply that rule, it's 2 raised to the power 5 plus 1, and this gives us 2 raised to the power 6. So the product rule is satisfied here. And what about the second sum? 4 raised to the power 5 into 4 raised to the power 8. It is 4 raised to the power 13. And if I verify the rule, I can write it as 4 raised to the power 5 plus 8, and this is also equal to 4 raised to the power 13. Right? So the product rule is satisfied. And in this case also, it is t raised to the power 3 plus 2, which is equal to t raised to the power 5. And in the fourth problem, since the bases are not the same, our product rule could not be applied. So the bases have to be the same so that this rule can be applied. And let's quickly see one more example. The sixth example. Let's have 5 raised to the power 6 into 5 raised to the power 0, which would be equal to 5 would be multiplied 6 times, right? 6 times. And second, this one, let me change the color for this. This is 5 raised to the power 0. So 5 would not be multiplied at all, no times. So I don't even have to write a 5 since it is no times. So what I get ultimately is 5 raised to the power 6. So if I apply this rule here, it also satisfies, because 5 raised to the power 6 multiplied by 5 raised to the power 0 should give me 5 raised to the power 6 plus 0, which is equal to 5 raised to the power 6, which is the same as what I obtained before. So this product rule is satisfied. I hope you followed what the product rule of exponents is. Let's see other rules in our other videos. Thank you.